Everyone has their own clock, but their clock shows something personal. That is to say, I'm used to saying time passes. That's an experience we all have. Time passes, well, yesterday I did this, I did that, last night I slept, I woke up and all that. It marks in a certain way the passage of time. Except that in the physics of space-time, you can't say that time passes. And in the end, when you think about it, it's not really time that passes, everything I just said. It's more like I'm the one passing through time. That is, I'm the one who passes. And I'll use an analogy. I take my car and I'm going to take the highway to go from Paris to Lyon. Well, I want to say I'm in my car and I see the highway. The countryside goes by, I see the signposts go by, I see the highway go by. No, it's me who's going along the highway. The highway, it's always there, it hasn't moved, it's me who's passing by. And in space-time, it's kind of the same. For me, space-time doesn't move, it doesn't flow. Nothing flows in space-time. It's me who experiences one event after another. And since an event is a point in space-time, I experience a point, I occupy a point, and then another point, and then another point, and then another point. There is a continuity and it draws a line in space-time. Donc, qu'est-ce que... So how can I be represented in space-time? By a line. A continuous line, which is the line that connects all the events I experience one after another in space-time. A bit like when I trace the highway, when I travel along the highway, I trace this line that makes up the highway, which consists of all the points I have occupied successively along my journey on the highway. Here, there is something I will call my world line in space-time, which is the continuous juxtaposition of all the events I have experienced. From my birth to my death, I will draw a line in space-time. And this line, from the point of view of relativity, is me. What am I? I am that line. And if I take a point on that line, that's me now. Another point further along, that's me tomorrow. Another point on the other side, that's me yesterday. And for example, you have a world line, and it just so happens that right now our two world lines have crossed. And then you're going to go home, I'm going to go home, our two world lines will go off in different directions again. So what is the duration that I experience, the duration that I can measure, that I can feel? Ultimately, it's the length of my world line in space-time, because in space-time there's something that allows us to measure the lengths of lines, and that's what I call duration. And you can see that if, for example, I haven't moved between yesterday and today, so I'm going to draw a kind of straight line in space-time. You, on the other hand, have moved, you've gone on a trip, I don't know, and you come back. You traced out a whole line in space-time, it's simply longer. Except that it turns out, well, that's one of the mysteries, or rather the peculiarities of physics there in space-time. It's that when you draw a line that in the drawing looks longer, actually, the duration is shorter. Well, that's a bit paradoxical. It's something that's hard to understand, but that's how it is. Because if I go back to the famous Langevin twin experiment that I described earlier, there's one twin who stays still. Since he remains stationary in space-time, it means he follows a straight line. In the end, he doesn't move, so he stays in the same position, but still, in the dimension we could call the time dimension, which for him is the time dimension, he describes a straight line. His twin brother, on the other hand, goes into space and then comes back. At some point, he turns around. So in a way, he describes a broken line. If you were in normal geometry, the broken line would be longer. In space-time geometry, the broken line is actually shorter. And that's why the twin who traveled experienced a shorter duration than the twin who stayed still.
I'm just taking this opportunity to follow up on that. I saw a theory that says we all move at the speed of light in space-time, and actually we distribute our speed between time and our speed in space.
So, no, there have been theories like that, but that would mean there's a dimension, a fifth dimension, for example, and that partially we would be moving at the speed of light, but part of our speed would be in this unobservable fifth dimension. Well, that was a theory that was proposed, but it wasn't accepted. So, no, we are not traveling at the speed of light. We are traveling at a speed lower than the speed of light, except that once again, the notion of speed is relative, as you know well. For example, let's say we both leave by car, each of us going, let's say, at 50 kilometers per hour in opposite directions. I'm in my car, and I say, from my perspective, I'm at rest in my car, and you're moving away from me at 50 plus 50 at 100 kilometers per hour. You say, no, I'm at rest while you're moving away from me at 100 kilometers per hour. So who's right? Well, there's something called the principle of relativity. If I say I'm at rest and you're moving away from me at 100 kilometers per hour, or if you say that you're at rest and I'm moving away from you at 100 kilometers per hour, it means exactly the same thing. Yes, only the relative speed makes sense. What is certain is that we are moving away from each other at a speed of 100 kilometers per hour, but saying that I'm the one at rest or saying that you're the one at rest, it doesn't make any sense. It's just a matter of convention. Obviously, I want to say that I'm the one at rest, and you want to say that it's you. I'm no more right than you are. So the notion of rest doesn't exist. But precisely what's interesting about space-time is that whether I'm quote unquote at rest or in motion, either way, I'm describing a world line. So whether this line represents rest or not, it doesn't make any sense. What's interesting precisely in this view of space-time, one of the main advantages is that this notion of the relativity of speeds is included in it. The notion of rest no longer exists. Everyone moves through space-time second after second, and that simply what I call the flow of time is ultimately my movement through space-time. And what you call the flow of time is your movement through space-time. It's not time that flows, it's you who flow through space-time second after second. And whatever you do, you will never be able to stop living 1 second after another, after another, after another. You will constantly move from 1 second to the next. Whatever you do, try to stop, well, no, you can't. And that's the great mystery, actually. Why don't we live our life all at once? Why do we live it moment by moment? You can ask yourself that question. Physics doesn't answer it, nothing does. And that's the great mystery. And why is there a difference between the point on my world line that represents tomorrow and the point on my world line that represents yesterday? Me tomorrow, me yesterday. If I draw my world line, it's the same thing. Yet I remember the point from yesterday and I don't remember the point from tomorrow. How come? What is the answer to this question? We have no idea. Why do I remember yesterday and why don't I remember tomorrow? Well, I think the big mystery, which we could still call the mystery of time, even if time doesn't exist, is that it's what makes the difference between what will happen to me tomorrow and what happened to me yesterday. Well, the only difference, because probably the same thing will happen to me tomorrow as yesterday. I don't know. I'll take the subway, I'll get into a car, I'll sit down at the table for lunch, etc. When I look at this in a year, there will be no difference between what I did yesterday compared to today and tomorrow compared to today. There'll be two events that are pretty much the same. Yet today I see it as very different since I have the memory of yesterday's. And what makes it so that I remember what happened to me yesterday, but I don't remember what will happen to me tomorrow? No one is able to answer that question. I'm not sure if it comes from physics, my brain, or my consciousness. No one knows. It's a great mystery that I think we're not ready to solve. It's what gives us the impression of time flowing.
By the way, speaking of the difference between yesterday and tomorrow, I also see that we're moving toward tomorrow while yesterday is inaccessible. Can we?
That's another question. Could I go back to what I experienced yesterday? That's what's called the closed timeline problem. If I wanted to go back, whatever happens, I'm describing my world line second by second, point by point. If I wanted to go back to yesterday's point, my future line would have to go back in space-time and pass through the point I occupied yesterday. Or, let's not be too demanding, let's say next to the point. because going back exactly to the point where I was yesterday would be impossible, because that would mean I don't remember what happened today. Whereas since I would be in my future, I can remember that yesterday I didn't remember what is happening to me today. So the idea that I go through the same point again, it can't work. On the other hand, the idea that I pass by the same point again, for example, there's a short story by Jorge Luis Borges called The Garden of Forking Paths, where he tells the story of his hero. He sits on a bench and sees a young man next to him, and who sees a young man who still seems familiar to him. And actually, the hero, he's 40 years old. The young man is himself at 20, which means that the guy described a world line that's not completely closed, but almost closed. And basically, in his future, he finds himself next to himself at 20 years old. So the question is, does physics allow that? I wrote a book exactly on this subject called Time Travel. That's exactly what we call time travel. By the way, there's something a bit paradoxical. What we call time travel only exists if time itself doesn't exist. If time exists, you can very easily demonstrate that time travel is impossible. But precisely since relativity dit que le temps n'existe pas, one can ask the question, is time travel possible or impossible? In the language of relativity, that means, can there exist world lines that close? Well, not exactly, but almost on themselves. And the answer was given in 1930 by the physicist and mathematician Kurt Gödel. Kurt Gödel, who is better known among mathematicians, proved a famous incompleteness theorem about, disons, the foundations of mathematics. I won't go back over that, but that wasn't all he did. He was a friend of Einstein. He was a friend of Einstein, or an acquaintance of Einstein. He was a very singular character who had almost no social contact. Einstein was one of the few people he had discussions with, because they both worked at the same institute in Princeton. And from time to time, Gödel would walk Einstein home, or vice versa, and they had time to talk a lot, and so on. A little anecdote, by the way, a little advertisement. A book is going to be published. I don't remember the name of the publisher, but it's under the direction of Jean-Marc Lévy-Leblanc, who is publishing a book of fictional letters to Einstein. That is to say, he chose several current physicists or philosophers, by the way, or others, and told them, write a letter to Einstein, imagining that you are either a philosopher, a physicist, or whoever you want. And in fact, I wrote a fictional letter, assuming it was a letter that Gödel had sent to Einstein, where in fact he was talking about those very problems. So the discussions between Einstein and Gödel are very interesting, and Gödel was the first to show that, at least from a formal point of view, that doesn't mean it exists in the real world. But in any case, that from a formal point of view, there were solutions in general relativity where there could actually be almost closed world lines. That is exactly what described this time travel that I just mentioned, according to Borges' story. Einstein was not very satisfied with these solutions, because for him it was something that could not happen. And to continue the anecdote, the physicist Stephen Hawking said, well, I think things like that shouldn't be able to exist. So he proposed adding an extra law to relativity by saying a solution of general relativity is only admissible if in that solution you cannot find closed world lines. Well, that's called the chronology protection conjecture, I think, because he said maybe it's a conjecture because it's something that can't be proven, with the idea that maybe one day we'll still manage to prove it. So there you go, chronology protection conjecture. I think that's what he called it, the exact term he used. But anyway, there you have it. So among physicists today, let's say we can see two categories. There are those who say, well, no, Hawking was probably right. This kind of thing shouldn't be able to exist, so we reject the solutions that allow it. Some say, as long as we haven't proved it's impossible, it's possible. Others are in between and say, well, whether it's possible or impossible. Anyway, it's interesting to study them because it teaches us things about relativity, about the solutions of the theory, about what time or space-time is, etc. So it's always interesting to have these investigations. By the way, this is related to a fundamental problem, which is the problem of free will, because I'll take Borges' example again, even though it's obviously a bit, how should I say, speculative, but let's say, suppose that at the age of 40, I'm sitting next to myself at 20. Well, being 40 years old, I remember what happened to me roughly between the ages of 20 and 40. And for example, I know that I moved to live in a house, the house caught fire and so on. A lot of misfortunes happened to me and so on. So I'm going to tell my, I don't even know what to call him, younger self, listen, whatever you do, don't move into that house because a lot of bad things are going to happen to you. And so my double at 20 got the message and he's going to say to himself, I'll try not to go through all that. Except that for me, it's in my past, it's lived, it exists, and what has existed can't be changed. It's a paradoxical situation because in the end, that guy is both in his future and in his past in a way. And precisely that's possible in space-time. Whereas if time exists, it's completely impossible because time is linear and one-dimensional. But in space-time, it's not at all forbidden to imagine a situation where I'm both in my future and in my past. That's the case here. So my double, let me pick up the story at age 20, will do everything he can to avoid living in that particular house. But what does physics tell us? It's a kind of consistency principle. It has been shown that this principle must apply if this situation occurs. Whatever he does, he will be unable to live in that house. Since it was in my past, it happened. And whatever happens, what's in the past is in the past, it happened. It can't be that it didn't happen. So no matter how much he wants to, he can't do it. And often we talk about the grandfather paradox. That is, I go into my past in this way, I see my grandfather and I kill my grandfather. And if my grandfather is dead, he can't have a child. So my father doesn't exist. If my father doesn't exist, I don't exist. So I couldn't travel back and kill my grandfather. If he isn't dead, I exist. There's a kind of paradox called the grandfather paradox, which has often been used as an argument to say that time travel can't exist. Well, yes, it can exist, but if I ever find myself in a situation involving my grandfather, well, in that case, physics implies, the consistency of physics implies that I can't kill him. That is, I pull out my gun, it won't work, or at the last moment I have a change of heart. I don't know what will happen, but in any case, it's impossible. That means my free will doesn't exist in a certain way. And the only way to know if free will exists or not today, well, that's it. It's time travel. Otherwise, I can't know. That is, if I decide tomorrow to live in this house, is it really me who decided it, or was it my destiny that was already written? It reminds me of the story of Oedipus, who learns from the oracle that predicts he will marry his mother and kill his father. What does he do? He runs away to avoid killing his father and marrying his mother. He gets as far away as possible, and things happen so that he meets his father at a crossroads and kills him without recognizing him. And then he will arrive in the city and eventually marry his mother without recognizing her. So everything he did to prevent his future from happening caused his future to happen. And so it's a reflection that seems very interesting to me about free will and how he knows that this future happened because he knew about this future. We don't know our future. except the only situation where we can know our future is precisely time travel to the past. If my 40-year-old self when I'm 20 already tells me my future, I can do everything I want to prevent it from happening, but it will happen in some way in the past. Well, it's a bit paradoxical, I admit. It's completely contradictory to the existence of time, but that's how it is until further notice. It's compatible with general relativity, with contemporary physics, until one day maybe someone will prove otherwise. But so far there is absolutely no impossibility, at least logically, for it to happen.
All right, so that also means that the present, the past, and the future exist somewhere?
So now it depends on the meaning we give to the word exist. For example, what you need to understand is that the notion of the present is not defined. Because saying, for example, that a certain event is in the present would mean that it is simultaneous. But as I was explaining a little earlier, it's impossible to decide whether two events are simultaneous or not. That is, whether the supernova explodes before, after, or at the same time as I am speaking, it doesn't make sense to answer that. Because for me, it will be before, for someone else, it will be after, for yet another person, it will be at the same time. So the present is before, it's after. The notion of the present doesn't exist. So if the notion of the present doesn't exist, I can't say that the only thing that exists is the present. So what could we say?
On pourrait dire, bah, ce qui existe, c'est le présent.
So if I say, when I see you in the present, that's not true. Because light doesn't take very long to go from you to me. It takes, I don't know, let's say a billionth of a second maybe. So when I see you a billionth of a second in the past. And you see me a billionth of a second in your past. So if we say, the only thing that exists is the present, that means we know nothing about the present because we don't know it yet. We'll know in a billionth of a second. If, for example, I said, what's happening right now on the planet Mars, I can't know that. I could know it in 8 minutes. That's independent even of space-time, even in the ordinary conception of time.
Si se passe quelque...
Suppose that, for example, the sun suddenly explodes, I would only know about it in 8 minutes because the light from the explosion would reach me in 8 minutes. So the sun no longer exists at the moment I'm speaking, and I can't know it. I will only know it in 8 minutes. So I can't know the present. So if you're in the situation where you think that what exists is the present, that means you can't know anything about what exists. And that everything you know doesn't exist because it's not in the present. So this conception of the world that we call presentism is incompatible with physics. Well, unless you're willing to admit that you know nothing about what exists and nothing you know or think you know actually exists, well, that's a bit of an extreme position. So how do you get out of this? You might say, especially if you believe in space-time, well, I don't see how you could not believe, because that's what physics tells us, that the present is not a well-defined concept. So you could say that what ultimately exists is what is in the present and what is in the past. The problem is that what is in the past for me might be in the present for you or in the future for you. And in any case, the past for me is not the same as the past for you. Because, for example, let's suppose that in my past, I don't know, there's something I did a few minutes ago, I don't know. There, I got out of the taxi a few minutes ago. And there's a friend on planet Mars who's watching through a telescope. He hasn't seen this event that happened for me 8 minutes ago yet. So for him, it's not in his past. It's in his present. So that means what exists for me, if I believe that what exists is the present and the past, what exists for me doesn't exist for him. So the notion of what exists is different for me, for him, for you, and so on. So that doesn't work either. So the only thing that's compatible with relativity is to say that what exists is all the events, both those that are in the future and in the past, as well as in the present. Even if these notions are poorly defined, all the events exist, both what will happen to me tomorrow and what happened to me yesterday. We're coming back to the discussion from earlier, and what's surprising, let's say, is that what will happen to me tomorrow has the same status of existence as what happened to me yesterday. But the only thing that differentiates them is ultimately that I can't know them in the present moment. Otherwise, there's nothing special about what will happen to me tomorrow compared to what happened to me yesterday that could make a difference, except for the fact that I don't know it. But the fact that I don't know it might be something that's personal to me, that depends on me and not on the laws of physics.
In fact, it's really our whole conception of time that we need to reconsider. Saying, go back to the past implies that there is a present, and actually implies that, for me,
there is a present, but in the universe there is no present. Saying that an event is in the present doesn't make sense, even though it's true. It's true, depending on whether it's me. My friend on Mars presses a red button. For me, it's simultaneous, so it's in the present, but for him, the moment when I press the red button, which for me is simultaneous. So the two events are in the same present in a way. For him, I pressed before, for example, so it's not in the present. For him, this notion of the present doesn't exist in space-time. Basically, to put it another way for you, space-time, let's say, is a big hole, it's a huge structure. If I want to say what is the present in there, I have to cut a slice, and I'll say this slice, it's all the events that are in my present, in the present, because this slice, it will cut my world line at a certain moment, and I'll say that's the present for me at that instant. Except that I can make the slice like this, I can make it like that, I can make it like this, I can make it pretty much however I want. And so there is no notion of the present. It's something conventional. There isn't a prescription. Well, there is one. For me, it's not the same as for you. It's not the same as for another astronomer. So the notion of the present in space-time doesn't exist. We can create it. We can create one by convention. That's actually what we do when we define time, because in a certain way, if I choose the clock I mentioned earlier, the Parisian clock, for me that's what time is, and it roughly corresponds to the direction of my world line in space-time, which I call time. What for me is the flow of time is the path of my world line in space-time. Since you and I don't have the same world line, what you call time is not the same thing at all, because it's the path along your world line. Obviously, if you look at things on a very, very large scale, they're very, very close. So by making an approximation, which is that of the accuracy of our watches, they are indistinguishable. All humans on Earth have the same world line to an accuracy of about 1/1,000,000th, let's say. But when we look at things more closely, they are completely different. And what I call time is along my own world line. What you call time is you along your own world line. And what am I going to call the present? Well, it's, let's say, everything that is in a certain way orthogonal to my world line, but what is orthogonal to your world line? Since it's not parallel to mine, it's not the same thing. So the present for me and the present for you are two different things, even if we're talking at the same moment in a certain way. Well, all this is hard to express because I'm using terms like present, the moment.
Un moment, ça n'est pas...
We must be in the same place for it to be the same moment. Otherwise, it doesn't make sense. Since this idea of simultaneity doesn't exist, we need to rethink the entire language. That's what's also difficult. It's that we have to abandon our intuition, but our language is based on our intuition, so we have to use a very special language. We're not allowed to use the word time. We're not allowed to use the word simultaneity. We're not allowed to use the word chronology. I'm obsessed with time, obviously, so you have to be careful. You have to use proper language. So the use of the term duration, it's completely acceptable. Duration, proper duration, as I was telling you earlier, because what I'm measuring is always a duration. And when, for example, two clocks are desynchronized, what is a clock after all? It's something that measures a duration, even your watch. You might think your watch measures time, but that's not it at all. What is your watch? It's nothing more than a stopwatch. It measures the duration from when you set it to the correct time to when you check it. Except this duration, since you set it to the correct time, starts at a moment you know. Well, the watch automatically adds the duration it measured to the date you indicated when you set it to the correct time, and that gives you today's date. But the watch is an instrument that measures a duration. There is no instrument in the world that measures time. An hourglass measures duration, the duration for time to pass. A watch measures duration because a watch oscillates with a constant period. In principle, if it's a good watch, this period is the duration of one oscillation of the watch. What does it do? The watch, it counts the oscillations, so it counts the number of times the short duration of the oscillation passes. So it's an instrument that measures a duration, a watch, a clock, whatever you want, whether it's the oscillation of a quartz, the oscillation of a pendulum, it doesn't matter. It's based on a certain duration, which is the period of an oscillation. And by counting these durations, we measure a duration. So there you have it. It's an instrument that measures durations.
Mesure pas le temps. Et
This duration, once again, is a way of expressing it. The length of the world line that I travel in space-time is something that is well defined in space-time, but once again, the length of my world line has no. Between two specific points, there is no reason for it to coincide with the length of your segment of world line between those same 2 points. And that's the answer to what is called the Langevin twins paradox, for example, or the answer I mentioned earlier. Of the 2 clocks you take whose readings coincide perfectly, you take one upstairs, bring it back down, and they no longer coincide. Because each one has measured the duration of its own history, the duration of its world line, between the moment they separate and the moment they meet again. And these durations have no reason to coincide, and they do not coincide.
All right? So here, we've only scratched the surface of the subject. There are quite a few books that talk about it, including one that you wrote. Can you remind us of the name?
Time Travels, published by Sui. I think with that, people can find the book.
Okay, so we'll look for that.
I wrote a second book, which is on a similar topic called The Age of the Universe. Because the big question is, if time doesn't exist, what do we call the age of the universe? And let's say it's a rather specific question within this issue surrounding time. And by turning more towards cosmology, that is the evolution of the universe, how can we date an event in the universe? What do we call cosmic time? What is the age of the universe? So another little book, maybe a bit more accessible, a bit easier to read, but focused on a slightly more specialized topic. So it's called The Age of the Universe, and it's published by Human Science, which is a collection from the publisher Humensis.
Okay.
It came out about 2 years ago.
We'll put the links in the description. So that marks the end of our interview. Thank you, Marc Laquies, for this interview, which was extremely interesting. And I think it's going to make a few people think.
I hope so. That's the goal.